thank you to the organizers for inviting me to talk to you about FET. When I was asked to give you a brief introduction about FET, I thought it's a very easy job because I guess most of the people here know what FET is about, and there is no need for me to talk a lot. So I took some slides from a standard presentation, put them together, and then I realized that there is a problem in what I have prepared using our standard slides. Namely, the word innovation is not mentioned there. And that already tells you that we do need your help. I mean, I don't think we are doing that good of a job of going beyond the purely scientific research, beyond delivering nice papers, and bridging the gap, or maybe there is no gap, but that's another thing maybe we should discuss here today and tomorrow, between the basic research, scientific, fundamental, maybe applied research, going from FET towards the mainstream research, and from there to industry eventually. So I worked a little bit more on the presentation, and here I would like to emphasize further what Eric said about things not being exactly fixed already. Actually, things are very much in motion right now. I mean, there are discussions going all the time. There were decisions made yesterday, which I'm not sure they still hold. So you should keep that in mind, that some of the things I'm going to present to you probably are not going to be exactly that way when everything is finished, hopefully by the end of this year. That said, very briefly, as you know, Horizon 2020 is not simply FP8, as one may think. It's a single instrument which combines the framework programs with the competitiveness and innovation program and with other instruments we had in the previous period, in order to give the opportunity that together they produce much better, much more focused approach to funding science. So, as you know, probably already, there are the three main pillars. We have the excellent science, we have the societal challenges, and we have the industrial leadership. And what we're talking about here, about FET, that belongs to the excellent science pillar of Horizon 2020. And in the excellent science pillar, there are four main players. Three of those were already there in the previous framework program. And the fourth one, represented by our hanging in the air tree, FET, is the new recognition that what we have been doing in FET really belongs to the excellent science pillar. So it's the new kid on the block, but not exactly. I mean, we have been here for quite some time. We just acquired our rightful place within the excellent science pillar. And again, when preparing my slides, I had the numbers here about the distribution of the allocation of money to the different components of the excellent science pillar. But again, I realized that these numbers a long time ago already are not that relevant. Numbers are the easiest thing to change. So we'll wait some time more to see what exactly the budget is of this. But roughly, the size of the blocks represent the relative size in terms of funding for the different components of the excellent science pillar. So that's a very new addition to my presentations from some discussions a couple of days ago, literally. And you can think about this as being the work in progress on the mission of FET in Horizon 2020. So what we have here is that FET aims at radically new technologies. We shouldn't forget that we're thinking about technologies here by exploring novel and high-risk ideas building on scientific foundations. Then FET promotes research beyond what is known, accepted, and widely adopted, and fosters novel and visionary thinking to open promising paths towards, again, powerful new technologies. The supported research will be multidisciplinary and positioned between research driven by science and research driven by societal challenges and by industrial competitiveness, bringing closer science and engineering. So explicitly we would like to emphasize the fact that the FET research should move closer to the implementation, to the engineering, to industry. And FET will contribute to close the gap between upstream research and research carried out in societal challenges and in the mainstream units within the Commission. So this, as I said, work in progress on the mission of FET tells you that the emphasis definitely goes much more towards application, towards engineering, towards innovation, which is delivered through FET. So, as I said, I hope you will help us through discussions today and tomorrow define better what we mean by that. And the specifics about FET, which probably most of you know, since a couple of years ago already, FET consists of three main components. I mean, a couple of years ago, the flagships joined the two already existing components, FET Open and FET Proactive. So I'll very briefly talk to you about Open and Proactive. You can think about these two components of FET as, in the Open we have bottom-up research. In the Proactives, we use the bottom-up approach to define specific subjects, specific objectives, and then through these predefined objectives, we have top-down research, the idea being to try to encourage the emergence and building up communities. In more details, on FET Open, the main part of FET Open until this year was a challenging current thinking. Probably it's going to stay more or less the same. But as you probably know, it's light. In the sense, it's very easy to apply. It's topic agnostic. So there are no specific predefined topics when you apply through the FET Open scheme, aiming at fundamental breakthroughs based on novel ideas and long-term vision. So what I would mention here is that we did have specific actions focused on helping SMEs and young researchers, but definitely that probably should continue and be more focused. Until now, we had a fairly simple process, which was made even simpler. Up to last year, we had a two-step submission, two-step evaluation process. Currently, we are evaluating the results from the so-called FET Open Extract, which is a procedure in which the applicants, the proposers, submit a single 10-page proposal. In these 10 pages, there are 8 pages on scientific and technological excellence, 1 page on implementation, 1 on impact. And these proposals are being evaluated in 2 steps. First, we have the scientific excellence being evaluated by external experts. And those proposals which pass the threshold are being evaluated on implementation and impact, the last 2 pages. So that's the process. And we underwent to this process for the last 3 months. We are close to completing this first pilot. And I would say that so far the reaction from the scientists who applied is extremely positive about the whole procedure. I mean, it's understandable. It's really easy to prepare. No, it's not that easy. 8-page proposal with your scientific idea. Actually, one sort of negative remark was that the implementation of 1 page is too small, and people would like to have some more space in order to express really the scientific qualities of people who apply. But that's the FET Open Extract procedure, which I expect it to stay more or less along the same line in the next periods. I have this wonderful, colorful picture. You don't have to read. These are basically the projects, the titles of the projects which we have funded over Framework Program 7. There are 141. Actually, there are more from the last couple of batches. And the specific themes, which are even more difficult to read. You can see some examples about the very broad, diverse set of ideas being explored through the FET Open projects. So, combining the information from the FET Open projects, but also going through communications with the communities, discussing with various stakeholders, we move forward to the FET Proactive. We define specific objectives, and as you probably know, the approach of FET Proactive, the second component of FET, we have these fixed calls, typically once per year, maybe twice sometimes. As I said, the topics are defined bottom-up through FET Open portfolio analysis, consultations. Also, we use coordination and support actions in order to define the objectives for the FET Proactives. And then we have the standard procedure of evaluating these proposals and managing those. The idea behind FET Proactive, the main target we have in this approach, is to identify emerging communities in Europe doing science around certain topic. And once we identify it, we try to encourage this community through launching specific calls and help it grow. And there are certainly very successful stories about that. I can see here representatives of at least 1, 2, 3 communities which I recognize, which have been helped through our proactive initiatives. Just to give you an example, actually this is the set of objectives from here north of objectives which we have launched through the FET Proactive. Yes, and those are the last ones on the top. And most of them, this is even more difficult to read. Oops. When we talk about the proactive, actually, we mean not a specific objective which is launched once and then we'll forget about that. But when we launch an objective and we see that it's successful in starting to build the community, then what happens usually, we have a second or third call which helps this community even grow further. And these lines basically show you the connection between the various objectives launched in FP5 and FP6 and FP7, and certainly there will be more objectives launched in Horizon 2020 related to already existing objectives in the previous framework programs. So if you have been a customer of ours in some of these objectives, stay tuned. There's a big probability they'll appear again. That's it about FET Proactive. I'll hand the floor again to Wolfgang. Thank you.
Thank you, Rumen. Maybe just 2 points to reiterate from Rumen what he said. First, the mission of FET is somehow shifting. The mission is broader than just being the pathfinder and incubator for new ideas for ICT. So one of the reasons why FET is positioned under this excellent science pillar is the scope is by definition open. So it's ICT and everything beyond. And we have to master this challenge as well, how to be open and still be focused and being able to deliver. And I think the discussion we have as well here today links with this element, I think creating a kind of a different mindset towards the delivery of the FET results. So we have seen that, of course, customers, participants, beneficiaries, they're extremely satisfied by being under the FET program in the sense that they can help to raise their level of excellence in science and in the research. But we have the additional dimension to seek how do we live beyond that. And the flagships actually was probably an element which has been added to the schemes of FET to push maybe most far in that direction of innovation, because we say the flagships, they are rooted in science, they are science-driven, They're large-scale partnerships to address grand scientific and societal technological challenges. And the fact that the community asked us, the scientific community, could the Commission imagine to engage in commitments over a period of 10 years on a single initiative? That gives us a means and an opportunity to engage other partners than the usual partners in FET research. So what we see in the flagship concept, that industry is to gradually increase its participation over the lifetime of the flagships. And many colleagues said to me, Wolfgang, you're engaging in something which is mission impossible. How can the EU commit to initiatives like flagships over a period of 10 years when the framework programs are 7 years duration, a political mandate of a commission is 5 years duration? And I must say I accepted it has been a huge challenge to get this commitment, but in fact I think we got the commitment thanks to the courage of our Vice President. Nelly Cruz has been very instrumental in pushing for this kind of scheme to be added to FET. She is very much convinced that Europe, apart from being open in this research, like in the open and the proactive themes, where we with the community define those schemes, we need to add some focus where Europe can shape a focused leadership in specific areas. And this has been the driving motivation for the flagships. So there are a few discriminators, differentiators from the other parts of the FET. So the one thing is that a typical FET research project is 2 to 4 years duration. The flagships initiatives are designed to be supported up to 10 years. At the scale we have, I think, probably rarely seen or not seen yet on the EU level, at a scale of a budget of the order of 100 million per year per flagship, with 50 million coming from the framework or the Horizon program in the next near future. The flagships were designed as well to focus on a unifying goal. So they differ from just being a thematic orientation. We have invited the community to get together under tackling a common goal. So this has been itself quite a process, I mean, on shaping these initiatives. And as you may imagine, there was quite a debate on how we select the topics. And I'm glad that the Commission stood up to its announcement that we said the best we can get out for Europe is not by having just a political decision, but having a decision based on scientific excellence. And this has been put in place, and we had over the years put initiatives together. We have subsequent different selection phases. We have actually supported over a period of 12 months so-called pilot preparatory phase. This was for the most promising ideas, a kind of feasibility design studies, putting a strategic roadmap together, putting the partners together. I mean, collaboration of disciplines we have probably rarely seen before. And the flagships have been given rise to go far beyond ICT as well. And that in itself created the necessity to change the role of FET. I mean, we see now in the 2 retained flagships on graphene and on the Human Brain Project. I mean, graphene project has lots of elements in material science, applications to energy, to medicine, and so forth. The Human Brain Project has a very strong element of neuroscience. I mean, clearly outside ICT, but where ICT will benefit as well from this research. And this, I think, is exactly a model here, what we are trying to promote. But we have to see as well what are the implications for the FET Proactive, for the FET Open, when moving beyond ICT. I think I'm not going here to the details on the 6 candidates. I may just ask, who has been somehow associated or involved in FET flagships in the preparatory phase or before? Would you mind raising your hands? Okay. Do you want me to elaborate on the others who have not been engaged? I mean, I can say maybe a very quick word on those. I hope we're not taking too much time here.
Running a bit late.
Okay. 2 sentences per flagship candidate. So here it's just the kind of logo and acronym. There was a candidate on robot companion. This candidate on robot companion were looking at an entire new class of artifacts, particularly geared towards an aging society, where those robot companions would have capabilities, functionalities towards being sentient, enabling capturing of motion, and having different ways of interaction. I think rooted in strong elements of European research and with a clear perspective as well on looking at future industrial applications. The IT future of medicine was a proposal which is rooted in systems biology. The emphasis was towards a modeling approach from the gene, from actually representing data, physiological data, anatomic data, genetic data from individuals, and trying to develop personalized medicine. Future ICT was the so-called Knowledge Accelerator, an initiative which in particular tried to model and simulate human interactions on this planet. They had a particular participatory approach. How will the expected evolution be that in terms of risks on crisis management, looking at issues in the economic crisis, financial crisis, but as well looking at innovative aspects like new ways of governance, in particular like what is the role of social media. It very much links with a kind of concept of big data approach, how to make use of data which are available today. Guardian Angels was a project looking at nanoscale level sensors, self-powered sensors, really zero energy, and with a whole plethora of applications ranging from monitoring personal health to the environment and to energy applications. And the two winners are those here at the bottom, graphene and HPP, and I have two slides each, I think, on them. So graphene will be very short because we have here a colleague from Nokia who will give a dedicated talk on graphene. I mean, I guess most of you have heard about this, what is coined often the wonder material of the future. Graphene has immense properties. I mean, in terms of electrical conductivity, in terms of the way, I think the English term is malleability, and very difficult for a non-English, I think, to pronounce, but you can bend this structure, you can hammer it down like gold or silver, and it doesn't lose its atomic layer single structure. So it's a one atom thick structure which has a full range of potential applications in the use of materials, be that, for example, for new aircraft designs. It has health implications. It can be used actually that you can plug on, due to its connectivity, molecules to transport better medicine for treatment of different diseases. It has implications that we could develop new batteries, energy use. There are ideas maybe to use membranes of graphene for desalination. So a whole range of potential applications, and still there are major scientific research challenges behind it. And what graphene is trying to look into is a class of two-day layered structures, so graphene and similar graphene-like materials. And the beauty of this flagship is certainly, and that fits the spirit of innovation, it has this ambition to reach from the lab out towards production and manufacturing of the material. So here we have huge expectations. I know we have put the bar high for those projects. That's maybe not a surprise, but there is as well some essential funding going into that. One element I've not mentioned is in these flagships, what is as well a very strategic element for research policymakers is we expect these flagships not to be European-led, framework program-led initiatives, and the member states run their own programs. The idea is really here that national programs are aligned towards a common European objective. This in itself is a challenge. I mean, we're trying to see how we build up like co-ownership of national funding agencies and ministries and engaging in this. And this is a process which we will continue to work on. I mean, we have now had a call as well for a so-called ERANET, where funding agencies get together. There are more than 20 funding agencies, and where they put their plans together to support the two flagship initiatives. Human Brain Project is the second European flagship which has been announced by Vice President Nelly Cruz by the end of January. This as well is equally a very ambitious project. I think sometimes it's controversial, discussed in the scientific community. Some colleagues from neuroscientists, maybe those who are not part of it, they think this is overly ambitious because they're trying to model the human brain from a subcellular function from the genes up to the level of higher brain functions, be that cognitions, be that a status of mind. And this in itself, of course, is a huge challenge. It's not only neuroscience. The project includes aspects of developing new ICT architectures, new computing architectures, so-called neuromorphic computing, which is directly a spin-off from the understanding on how the human brain functions. And of course, if this project is successful, it would enable as well a better way of looking at new approaches on the way on treating brain diseases. I was on a conference end of last month in Dublin, on the conference called Healthy Brain, Healthy Europe, where policymakers met together with researchers, together with associations from the health sector, and you would not believe how much brain diseases and the cost of brain diseases have increased over the last 2 decades. There's a figure of 800 billion being the cost per year on brain diseases. I was yesterday in a meeting with the Health Research Program Director, and she said, imagine only if 10% of that cost would be put in research. And we are far from that. We're putting here less than 1% basically in the human brain flagship. So this is as well the second initiative. And I would now make some remarks in the context more of this specific conference, trying to frame the discussion, trying to provide some ideas. So we were talking about the change of mission and what actually is changing. I mean, there are a number of parameters changing in the context of the Horizon 2020. I said that if we are to explain the mission in one word, the mission of FET is putting knowledge or turning knowledge, transforming knowledge into technology. But of course, there's still a science dimension because this may require as well to augment the scientific foundations. So this is the key element, what we see as the mission of FET. And this may imply that we have to adjust some of the parameters, what we expect from the projects and what is the project delivery, as Eric already said. Probably we go beyond what is typically a scientific result in publication. We are working in a new context with some new paradigms like open access, open data. I mean, there have been policies behind open access to publication, open access to data, in order to facilitate reuse and making it more cost efficient for the scientists and for the community as a whole by reusing data. So I think this is as well an element where FET tries to be the forerunner in making use of these new concepts and applying those concepts. Now the question is, are we always working with the right stakeholders together? The huge majority of FET participants, beneficiaries, are of academic nature. Of course, we have some SMEs, we have some industry partners, but very often they provide an infrastructure and they're not the drivers of the project, and they're even sometimes not the ones who actually really pick up the results. We see as well that the schemes, the 3 schemes, they're very complementary, and maybe the measures to look on how to get them best to deliver in terms of innovation, we have to maybe differentiate from one scheme from the open to proactive and to the flagships. Now this brings us to some questions. I hope you can read them for the back. And these questions are kind of a brain dump, what I have just prepared in order to stimulate a bit the discussion. And I think it's very important, as I said, 2 aspects. On the one hand, what is to take account of what is the mission of FET, and secondly, to have some shared understanding what is the challenge in terms of innovation for FET. And I think this can raise the following type of questions. And I think these questions are by no means exhaustive. This is really just a personal a reflection on the issues we are facing, we are challenging. So the one question is, what do we expect? What does it mean for you as a potential beneficiary, a present beneficiary in FET, a future applicant for FET research? What is the expected result and outcome of a FET project when it's in open, when it's in proactive, when it's in a flagship? But maybe we have too often just looked at the end of a contract, and at least from the Commission side, we have not invested to look beyond what comes after that. And I think we have heard the issue and the challenges on innovation transfer, on taking it up. And I mean, in my personal view, for example, I believe we have even a challenge, not only one valley of death when it comes to the innovation, which is the typical valley of death we refer to is we are strong in developing maybe new technologies, new products and services, but we are not shaping the markets. But I think in terms of FET, we have even a valley of death by delivering the FET results to the mainstream research and beyond, at least in a majority of cases. So there's the question of incentives. What are the kind of incentives required to be more efficient and more effective in the delivery in terms of innovation? There's the question on the stakeholders. Are we having the right mix of players in FET? Should we have some specific actions maybe which are required at the end of a project where we engage other partners, other stakeholders to take the results further? Then there's of course the question, what are the measures to be taken within FET? And what is the response maybe required from the innovation ecosystem which is outside FET? So I think ideally we would have to look and have some discussions as well over these 2 days more on what are the most promising innovation systems where FET results can flourish, how to inject them, how to take them further. And in the end, as I said, the mission is really to deliver towards the societal challenges, towards the industrial and technological leadership activities. I think that's nearly the end of my presentation. And I think that the last slide here is more or less summarizing what I have been said. I could present it as a conclusion slide. So we have to think about which measure for which schemes to make this impact on innovation more visible, more tangible. And I think this is really the overriding kind of questions and challenge for these 2 days, how to increase the impact on FET on innovation. Very often when we are describing our impacts, of course, we can list a pretty nice long list of anecdotes of good success stories. But are those impacts really systemic impacts on a broader scale? That's the wider challenge. So very often we're looking at impacts of an individual project, but we are not systematic in saying how a FET proactive has delivered for a whole industrial sector. So we have to look at different dimensions. And I equally see that on the flagship side. I mean, we have a plan to deliver, but whether it will work and what are the first reflections to even improve that delivery, I think is an open issue. We have to see how we link these two worlds, the worlds of science and research with the industry side. I think this is this second gap of valley of death where I think we have to engage and to discuss on. And I think there's then a final question as well. How do we measure improvement in terms of delivery on impacts? And I think this is as well one of the relevant, pertinent questions. I would like to close here, and I'm looking forward for a very interesting 2 days discussion. Thank you very much.